Hey guys, my name is Tensor. Welcome to another Flutter tutorial video. In today's video, we will be starting a series on Redux in Flutter. One of the most commonly asked questions I get inside of the comments section of these videos is with regards to Flutter, Redux, and state management. I think I get these types of questions mainly because the counterexample that I used to demo Redux was not a very good example for more complicated programs. So I thought it would be a good idea to go in and show you guys a few more advanced examples which would help you understand why Redux is so powerful and why it's a great choice for state management inside of Flutter. For this application, we're going to be making a simple list project. This is a project that uses create, read, and delete. There's no update currently. And then in the next video, we'll expand this application by adding things like persistence and middleware, as well as a time-traveling debugger, which will allow us to step backwards through our state. Before we get started, let's just talk about a general overview of Redux very quick. So there are three major tenets that Redux follows. First, we have what's called a single source of truth. This means that when we have state in our application, we want to keep it in one place, and this is called a store. The second tenet is the fact that state inside of an application is read-only. This means that when we want to change the state in our application, we need to create new state rather than mutate our state. And the final tenet is that these changes to the state are made with pure functions. These are functions that do not have side effects, and they take the previous state as well as an action, and then they return a new piece of state as a result of that. In this application, we first want to define the model that we want to create. So I've created a little folder here called model, and inside of it, we'll create a file called model.dart. Inside of this model.dart file, let's make an import for Flutter Foundation so that we can use the required meta keyword, and then we'll create two classes. One of them will be called item, and this will just be a model of one of the items that we want to add and remove from our application, and then we'll make a class called AddItemState, which will be representative of the entire state of our application. Each of our items will have an ID and a body. The ID will be an integer and the body will be a string. And the ID will just signify which item is which, and then the string will be, of course, the text that will show up inside of the list. We'll make both of these fields final, and then we'll pass them into the main constructor for the item, and we'll annotate them with the required meta keyword. To keep consistent with the Redux way of doing things, that is to have immutable state, we want to create a copyWith function which will take various fields and then replace them and create a new object rather than mutating an old object to create a new object. So this copyWith function takes in both the ID, which is an integer, and then the body, which of course is a string. And then what we do is we return a new item where we check to see if the ID that we're passing into the function is valid and not a null. And if it is a null, then we grab the ID that's already in the original item. And we do the same with body. So if body is null, then we grab the original body. And if it's not, then we put in the new body. Now let's take a look at the AddItemState class. For now, our AddItemState is mainly just going to be a list of items. This means that our entire application state can be represented with a simple list of items. And of course, we want to add a constructor for our list of items to our AddItemState class. So AddItemState required this.items. And then to further streamline things, we can create another named constructor to make a new initial state, which is just an empty list of item, which is immutable or unmodifiable. For now, this is all we have to do for our state. Now let's move on to the Redux part of our application. So we'll create a new folder inside of our application called Redux. And we want to create two files inside of this folder. We want to first create a file called actions.dart, and this will contain all of the actions that our application is allowed to take to mutate the state inside of our model. And then we want to create a file called reducers.dart, which we'll use to define the various different pure functions which we're going to apply to our application state to make the changes happen. Let's start with actions.dart. First, let's import our model file. So in my case, it's redux_items \. And after we make this import, we can create classes which will define the items that we want to create. So we'll create a class called AddItemAction. Then we'll create two classes, one called RemoveItemAction, which will remove a single item from our app state. And then RemoveItemsAction will remove all of the items from our list. When building these actions, we need to think about what types of data we want to expose to our user interface to allow these changes to happen. So with the AddItemAction, we're going to create a static field called _ID and set it equal to 0 by default. This will allow us to increment the ID as the user adds new items to our list. Then we can, of course, create a final string called item. As mentioned before, we want to increment our ID, and we can do that inside of the constructor here. So when we call to the store to activate this action, we're going to instantiate a new class of AddItemAction. So this means we pass in a string of the item that we want to add to the list, and then this will automatically increment the ID, and then it will then call to a reducer, which will then allow us to actually mutate the state. Finally, for the AddItemAction, we want to create a getter, which will allow us to get the ID. Now let's look at the RemoveItemAction. In this case, I'm just going to use an item, and this will allow us to remove the item from the list. So we can just say, okay, RemoveItemAction has a final item called item, and then we just pass that item into the constructor. The other alternative would be to delete each item by its ID rather than by the item itself. At this point, though, it really doesn't make much of a difference with this particular application. Now let's consider our final action, which is just RemoveItemsAction, and the idea is this action is going to allow us to completely clear our app state. Now, with the RemoveItemsAction, we don't need any kind of external input from the user aside from them clicking a button. So we don't need any kind of data like an item or an ID or a string or an integer or anything like that. So we can just leave the class empty like this, and then we can just use it as a way to tell our reducer that the user has indeed clicked the button, which will remove all of the items from our state. Now that we've finished with our actions, let's now create the pure function reducer functions that will allow us to mutate the state inside of our application. We want to import our model.dart file and our actions.dart file. Let's create what's called our app state reducer. This is essentially the overarching function that gets called every single time we want to commit a change to our store. So we just take in an app state and then an action, which in this case will just be dynamic, and then we want to return a new instance of our app state. We can use this same pattern to create a more specific reducer called the item reducer, which will allow us to manipulate the actual list of item which is inside of our app state. We can chain the two reducers together by coming back up into our app state reducer, and then inside of where we're returning the new app state object, we can set into the items field a call to item reducer and then pass in state.items and then the action that's being called. Our first if statement will check to see if the action is an AddItemAction type. Inside of this if statement, we create a new empty list by simply just using some square brackets, and then we can take our old list, which we have inside of the state variable here, and pipe it into this new list here. We can use the cascade method to call the add method and create a new item object using our action ID, which, if you remember, is an ID that we're incrementing with the constructor, as well as our action.item, which is a string that's being passed into our action. So the string goes into the body field, and then of course this returns a new list with all of the original state and then the new item that we just added. Now let's move on to remove item action. So we'll write if action is remove item action. First we'll create our original list, which will be a list unmodifiable with a list from our state. So this is just a normal list with all of our items inside of it. And then we can use the cascade operator to remove the item from the list, and then it will create a new list without the item that we just removed. For our final action, which is remove items action, we just want to return an empty list, and we can do this either by writing a set of square brackets like this, or we can just write in list unmodifiable and then put in a set of square brackets like that. Either way, we still get back an empty list. If no action goes through the reducer, we just want to return the original state. That way, if we don't get an add item action, a remove item action, or a remove items action, then the state doesn't actually change. Okay, so this is all we really need to do for our reducers. As you can see, they're fairly basic functions. They just take in the state and an action, and then they apply that action to the state based on the type of the action. They will get a little bit more complicated when we start to look at middleware, but we'll talk about that in the next video. Now let's come into our user interface and actually start to build it for our application. So as you can see here, we've got a fairly bare bones application. We've just got a stateless widget, which creates our material application. And then we've got a build function, which builds out a scaffold that already has an app bar in it. And then the body of that scaffold is just a container. Before we go any further, let's get the dependencies that we're going to need for this application. And we're going to need Flutter _ Redux, which at the time of this recording is at version 0.5.2. Inside of the main.dart file, we need to make 5 imports. We want to import Flutter _ Redux. We want to import Redux, which also comes with Flutter Redux. We want to import our model. We want to import our actions. And we also want to import our reducers. Once we've done that, we can create our store, and then we can wrap our entire application inside of what's called a store provider. To create this store, we can just go into the build function of our MyAppWidget and just create a new store with app state inside of it called store by calling the store constructor and passing in our reducer followed by the initial state for our store, which in this case is just our appState.initialState. Let's wrap our material application inside of the store provider, and then we pass in the type of our store, which will be our app state, and then we need to specify the store itself, which will be store. We'll add the rest of our application as a child to this store provider. Now that we have our store set up, we want to set up what's called our store connector, which will allow us to proliferate the store down to the rest of our application. And I'm just going to set it up right here inside of the body because I'm going to want to pass what's called the view model to 3 separate parts of our application. So the store connector will have the app state as the first argument, and then it will have the view model as the second argument. Now this view model class that we're creating here is essentially just the middle piece that connects the user interface to our store. So we can define what we want to expose from our store and from our UI to the other parts of our application. For instance, we know that we want to expose a list of items to our user interface so that we can actually display them inside of a list view. So we can create a field which will hold this list of items, which we'll just call items. And because I'm going to generalize this view model, I'm also going to add 3 functions to our view model, which will represent the actions that the user has to take to call one of our actions. So we'll have a function that takes in a string, and this will be bound to our addItem action. Then we'll have a function which will take in a item type, which will be our onRemoveItem action. And then we'll just have a function that takes in nothing, which will be bound to our RemoveItems action type. Now we can just set up the constructor. And then after we've defined the main constructor for this view model, we want to define a factory constructor which will allow us to take in the store and then create a view model class. Inside of this factory constructor, we need to define what these functions will look like so that we can add them to our new view model instance. The first function that we have is the onAddItem function, and so I'll create a new onAddItem function which takes in a string called body and then just calls store.dispatch with our addItem action being instantiated inside of it, and then we pass in the body. The other two functions will follow a similar pattern. We have the onRemoveItem, which just takes in an item type, and then the final one is the onRemoveItems type. Now I know creating functions like this may seem a little abstract at first, but essentially these are just the functions that we're going to execute every single time the user takes one of these actions. When the user adds an item to our list, which they'll do through pushing enter or the return key, after inputting a string into a text box, it will then call this onAddItem function. After defining these functions, we just want to return a new view model instance from our factory. That way every time we call our view model, it creates a new view model which we can then have access to inside of our different widgets. And you can see here we just set up our items field with store.state.items, and then we set up the three functions with the three functions that we created inside of this constructor. Now let's go back up to the store connector and sort of tie all of this together so it makes a bit more sense. The first field that we want to add to our store connector, is what's called the converter. This is just a function which takes the store and then converts it into the view model that we want to pass to the descending widgets. The second field that we need is the builder. The builder takes in the build context, and then it takes in whatever we return from the converter, which in this case is our view model type. We can then expose this view model to any of the children of this widget, which in this case is a column. Now we want to create the three different widgets which will be children of this column. So at the top we'll have a text box which we'll call AddItemWidget. And of course we want to pass in the view model so that we can call our addItem action. Then we'll have an expanded with a ItemListWidget inside of it. And again we'll pass in the view model so that we can access the ItemRemove action on each of these items inside of the list. And this ItemListWidget will just display the list, and then of course each of the items in the list will have a button attached to it which will allow us to delete that corresponding item. Then finally we have this Remove Items button, which again takes in the view model, and this will be responsible for calling the Remove Items action, which will delete the entire list. First let's start with the AddItemWidget, which will be a stateful widget. We're passing in the view model, so we want to define a final view model inside of the AddItemWidget class and then pass it into its constructor. And then because this is a stateful widget, we of course want to point it towards a state object which we'll call AddItemState, and we'll have this extend state with AddItemWidget inside of it. Because this widget is essentially just going to be a text form field, we want to create a text editing controller at the top of it. So we'll just say final text editing controller equals text editing controller. And then inside of the build function, we can return the text field, pass in the controller, and then give it a little bit of decoration so that it has some hint text. And we're just going to say add an item for the hint text. The real magic of this widget is going to happen inside of the onSubmitted field, where we have a function which takes in the string which is in the text box and then we can take that string and pass it into our view model on AddItem so that it actually calls to our store and then adds the item to our list. Now let's work on the ItemListWidget, which will be a stateless widget. Again, because we passed in the view model, we need to define the view model here and then pass it into the constructor of this widget. The main widget of this widget will be a list view, which will display all of the items inside of our app state. We can do this by calling model.items.map, and then we can create a function which will iterate through each of the items and then display them in the widget format. In this case, we'll take in each of the items and then we'll create a new list tile for each item, and then we'll take all of the list tiles and convert them back into a list of widgets, which will then go inside of our list view. Each of our list tiles will have a title, which will have the text of our item body inside of it, and then we'll have a leading icon button, which will have an icon of icons delete, which will just be a trash can. And then when the user pushes on that icon, it will call the model on RemoveItem and pass in the item that we've clicked on, so it will actually delete that item from our app state. Finally, let's create our Remove Items button. Again, we passed in the view model, so we need to define it and then put it through the constructor. And then we want to define the main body for this widget, which will just be a raised button. And when we click the button, we'll call on our Remove Items action to remove all of the items from our list. So the raised button will have a child of text which just says delete all items, and then on pressed we'll call model.onRemoveItems, which will then delete all of the list. And that should be it for our application. So now let's open up our emulator and run it and take a look at it. Here's our application inside of our emulator. You can see we've got our title, our text box. When we click in the text box, we get a keyboard. And when we want to add an item, we can just type it in and then click the checkbox, and you can see that it gets added to our list here. Each of the items inside of the list also has a button attached to it, which if we were to click, it would delete this item from the list. At the very bottom of our application, we also have the button which will delete all of the items from the list at once. So let's try out some of this functionality. Let's say I want to delete the middle one. If I click this trash can, it will then just delete the middle one. If I want to add another item, I'll just type in some random text and I'll hit the check mark, and you can see it gets added to the end of the list. And then if I want to delete all of the items, I can just click delete all items, and this will then remove all of them from the list. In the next video, we will talk about how we can deliberately use Redux to cause side effects inside of our reducers by using middleware, how we can combine different reducers together to make things a little bit more succinct, and how we can do a few other cool things with Redux. I hope you guys enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means, downvote it as much as you like. Have a good night.